In this lecture, we're going to discover why the pre-flop strategies that you choose are the very foundation of your post-flop play. The question that we're focusing on in this presentation is fundamental to making profitable pre-flop decisions. This question is, how does the construction of our pre-flop range affect the profitability of our post-flop play? What are we going to learn today? First, we'll see why equity share is a terrible model for making pre-flop decisions. We're going to visualize binary thresholds and also visualize payoff asymmetries to learn why these two factors influence our post-flop play, and we're going to discover how the set of possible post-flop outcomes affects the payoffs that are associated with entering the pot pre-flop. We'll tackle that first problem. Why equity share is bullshit. So I'm going to outline a naive model that a lot of players are using and has even been discussed at kind of a more formal teaching level in the past. This is not an attack on any particular theorist or player. This is an attack on a concept which is consistently applied and left unquestioned by either the player who utilizes the concept or, in the case of a teacher, his audience. The equity share model is generally misused by players in one of two ways. Either they believe that the pre-flop hand versus range equity represents the return they can expect from a hand in a direct manner. So an example of this is choosing to call a pot size open when in the big blind that would cost you 2.5 big blinds. The flop pot would then be 7.5 big blinds. So you have the 3.5 from the opener, 3.5 from you, which makes 7, plus the half a big blind from the small blind that's dead money. And the equity share model tends to argue for a call with basically any hand that has more than 33% equity because of pot odds. And that's as far as it goes. That's a mistake. The other mistake that the equity share model leads you to is people believe that the flop hand versus range equity represents the return you can expect from a hand in a direct manner. So let's say this big blind sees a flop of queen jack 8 and he holds jack 9 4 deuce. His equity against a tight range on this flop is 30%. And the pot is 7.5 big blinds on the flop. So he might estimate his return from the hand over the long run as just equity multiplied by flop size, and he thinks that by the time he's seen the flop, he's going to get back 2.25 big blinds. And we're going to see, as we explore the superior model that I'm going to present here, just how flawed that is. So thinking in terms of equity share distorts your post-flop decisions. Pre-flop, it leads to the following common errors. So if you believe in the equity share model, you'll do things like call almost every 3-bet because we have equity. You'll call almost every big blind heads up because you have equity. And when I say heads up, I'm talking about facing a single raise. I don't necessarily mean that heads up big blind versus like purely a button who's opening 100% is a mistake. I'm talking about the heads up in the more general sense. Calling almost every big blind multi-way because we have equity. So each of the mistakes above is going to be addressed individually within other lectures in this series, but today we're going to attack the model on a higher level. So the purpose of this section is to completely demolish the equity share model, and then we're going to replace it with a more complex and yet more accurate way to think about poker decisions. We're going to see that, first of all, equity share is applied inconsistently by those who cite it. It's also entirely disregards the context of the hand, and then I'm going to show you what equity really represents in most poker situations, and give you an alternative model to use. I'm going to provide new context-appropriate metrics for making pre-flop decisions as we go through the series. If an opponent opens from under the gun and is folded to us in a small blind, then if we expect the big blind to fold, the equity share model would have us call any time that our hand versus range equity is higher than 37.5%. So you can do this calculation quite simply. You divide your voluntary contribution to the pot. So if somebody's open to 3.5 big blinds, you're in the small blind having contributed half a big blind, you need to pay 3 more. The expected final pot size, if the big blind is going to fold, is the 3.5 that the under the gun has put in, the 3.5 that you've put in, and the 1 big blind of dead money. That totals 8 big blinds. And so, if the equity share model were valid, you would say 3 divided by 8, and you would play any hand that had more than 37.5% equity. So this entails some rather strange calls. You would be calling from the small blind with hands like ace, jack, 6, 3 suited to the jack, 10, 10, 8 deuce suited to the 10, or even jack 6, 3 deuce double suited, a remarkably weak hand in this context. Worse still, let's say you're in the small blind and you expect the big blind to call with a wide range of, say, the top 70% of starting hands, and this is very frequent what actually happens at the tables. Then you would say, okay, well, I expect it to be able to continue 3 ways as long as I have a hand versus range equity of more than 28.6%. Again, we do this calculation quite simply. We take the voluntary contribution to the pot that we put in, 3 big blinds, and we have 3 sets of 3.5 big blinds going into the final pot size that at least gets to the flop, and that's 10.5 big blinds. So 3 divided by 10.5 is going to be 0.286. So if you attempted to call with all of those hands, you would call hands like Ace 8-6-5 suited to the 8, 9-8-8-5 suited to the 8, and Jack 7-4-3 double suited. This is not an experiment that I encourage you to try. I've introduced this to demonstrate that even people who believe, or at least think that they believe in the pot odds / equity share basis for their calls, don't actually apply it in every situation in practice. So the other problem with equity share, and the deeper problem, is that it entirely disregards the context of the hand. So let's say an opponent opens from under the gun and the action is folded to us in the big blind. If we have a 3.5 big blind stack, then sure, we have a profitable call whenever we have at least 33% hand versus range equity. That makes sense. But we do know that being in position will confer an advantage to the player in position if the stacks are deeper. That's a fundamental part of poker knowledge that we generally accept. We also know that playing a stronger range confers an advantage to that player. That's essentially what a stronger range means. So it follows that even if hand versus range equity is not the best metric to use to evaluate a preflop decision, because we don't want a single factor to determine our entire preflop decision metric, we should still expect the average hand versus range equity required to make a profitable call to be a lot higher than the same one, the 33% for a 3.5 big blind stack in situations where A, stacks are deeper, and that's necessary, otherwise post-flop play is not relevant. B, your opponent has a stronger range, so we'll show why a stronger range can create payoff asymmetries, and it also dictates what I'm going to describe as binary thresholds. And C, your opponent has the positional advantage, and that's because having the positional advantage skews payoff asymmetries into your opponent's favour. Put more simply, it's easier to build big pots when you're in position. In summary, equity share is a terrible model for making preflop decisions because it disregards how the range versus range context affects the hand versus range post-flop play. In the next section, we're going to establish a more complete model for understanding how to make preflop decisions. This model will enable you to understand payoff asymmetries and binary thresholds, the two factors that are explicitly ignored by a naive equity approach. Let's now put equity into context. So in the following exposition, I'm going to use an example of a single preflop decision to introduce the core features of our new model for thinking about all preflop decisions. So our example is going to be that we hold Queen 8-7 deuce single suited to the 8 in the big blind, and we face a pot size tight under the gun open. It's folded around to us. So we can use a cool feature in Odds Oracle to model our flop equity distribution against our opponent's opening range if we decide to call. So this feature of Odds Oracle uses a series of n trials to generate a sample flop equity distribution. If n is sufficiently large, then that sample will converge to a very close approximation of the true flop equity distribution. Let's look at the steps in each trial. The first one is to deal a flop. The second one, the program calculates the hand versus range equity for that flop. And the third step is it adds this hand versus range equity instance to a bucket on a histogram. And this process is repeated for n trials, where n is a number you set. For the example that you're going to see, I used 15,000 trials, and the flop equity histogram basically converges long before that point. So a finished graph for our example looks like this. So here we've got Queen 8-7-2 graphed versus a 12% open, and you can see there's a variety of different flops, very few flops where it's exceptionally good. So you've got, you see on the far right there, near 100% equity when you're flopping, presumably queen, queen, queen is going to give you basically 100% equity, right? And then you've got a variety of frequencies ranging between, say around 15% mark, well, a bit smaller, let's say the 12% mark. You see that peak about 2.25% frequency, between 30 and 40% equity. You see a peak where you've got between 2.5 and 2.8% frequencies for those kind of mid-30s in terms of equity. So you can get an idea of what types of equity you're generally flopping against this tight open. So at this point, I want to introduce some variables so we can start putting our example into the context of a formal model. So what we're going to call XHR is the flop equity distribution for a hand H against a range R. I'm going to share it with you now for those of you who are a bit more mathematically inclined or would like to be, that XHR is a discrete probability distribution. I was going to put in a slide to start explaining what a discrete probability distribution is, but then I decided, look, the main purpose of introducing this model is not so that you can go off and solve a bunch of statistical equations. I'm more interested in giving you a framework to think about the game. I want you to have a better feel of what's going on. So if you are interested, go to stattrek.com, a suitably nerdy website, and that will give you a chance to learn a bit more about discrete probability distributions. When a player is talking about equity, they're usually referring to average equity. So we can define a function E of that flop equity distribution, of that XHR that we just saw, as the average over the flop equity distribution for some hand H which we hold against a range R which our opponent holds. So when you see this when you see this formalization, it's much easier for you to understand just why equity is so overused and abused in the current discussion of poker. Because there are infinitely many possible functions that we could apply to the distribution XHR. EX of HR is just one of them. So the reason that E of this, the average equity here is so useful at low SPRs is because it's a critical factor in simple push-fold strategies. There is nothing special about the average equity at high SPRs other than it's easy to calculate. I want to say a short aside here on minimum equity curves, because the flop equity distribution that I displayed in that histogram can be transformed into a hand versus range minimum equity curve, something like this. I like to use this minimum equity visualization more frequently when I'm teaching, so for those of you who've done private coaching with me, you're going to have seen this quite a bit, because it's easier to read off how often a hand has a certain threshold equity against an opponent's range. In this example, we can see that, say, Queen 8-7 deuce has at least 40% equity against a 12% opening range. So you see that 40%, we draw a line off, it intersects with, we draw a line across, it intersects with the slope of the graph at the 34% frequency mark. So Queen 8-7 deuce has at least 40% equity against a 12% opening range 34% of the time. Equity in the term flop equity distribution, and this is where it gets a bit confusing because you've got the colloquial term of equity, which, as I said, is actually labeling usually average equity, and then here we've got flop equity distribution where we're looking, in a way, it's an average equity, but it's not the average equity that people are talking about when they're talking about the pre-flop calls. So it's the probability that your hand is the best against your opponent's current range by the river. So implicit in this definition are two things. First of all, that your opponent's range does not change. Now in reality, you've got some set of future paths where your opponent's betting range will have a different equity against your hand than your opponent's check back range, and your opponent's bet flop and bet turn range will have a different equity compared to his bet flop check back range, and so on and so forth. It's also implied, when we take this seriously, that you actually get to the river, which is not always going to be the case. So the problem with hand versus range flop equity distributions is that they're very misleading when used in isolation. And this is because all poker hands are played in the context of a range versus range situation. This enables me to introduce range advantage. So if we return to our example where we hold Queen 8-7 deuce in the big blind, we face a pot-sized tight open, it's folded around to us, and we want to know whether Queen 8-7 deuce is a profitable call in this situation. So imagine that we face some range R1, we have some range R1, which consists of hands that we already know to be profitable calls in this situation. So say, for example, we have a range of hands that we know are profitable calls, but for the sake of argument, we don't know whether Queen 8-7 deuce is or not. So this range is going to consist of tens of thousands of hands for sure. Okay, so it's a very large number of hands in PLO, 270,000. And so we've got, just adding Queen 8-7 deuce is not going to dilute that range with any significance at all. So just adding Queen 8-7 deuce to that range, so you basically play the known range of hands that are already profitable plus Queen 8-7 deuce, is going to have a negligible impact on the range versus range matchup between us and the under the gun open. So you call adding Queen 8-7 deuce here to that range a perturbation on the range. We're now going to look at a selection of flop textures to examine the flop equity of Queen 8-7 deuce in the context of the range versus range matchup. So here we have four different flops. We have the 6-5-4 flop, where you see our hand versus range equity is very good. We flop the nut straight, and our range versus range equity is still pretty good. We're going to be ahead despite the fact you're out of position with a wide range against a tight range. You also see that the frequency which the big blind, so that's us, holds the set or a set or a straight is almost 20%, and our opponent only holds it 6%. We see on the Queen 9-7 that, yes, we flop top and bottom 2 pair, so you'd think, okay, this is a good flop for us, and it's true, it's a good flop for our hand. We are ahead of our opponent. However, range versus range, we only have 41% equity here, and we have about the same number of sets and straights, well, no straights of course, but about the same number of sets as our opponent does, although on average his sets are going to be better quality than us because he'll hold virtually no 7s and very few 9s, where he's going to hold the bulk of his sets will be queens. Then we see the Ace-Jack-7, where our hand versus range equity is only 18%, and our range versus range equity is dire, it's 35%, and our opponent holds 3 times as many sets as we do, and almost all of his are aces. And then finally we see the 7-6-3 board, where our hand versus range equity is such that we're a dog, but we're slightly ahead in terms of equity range versus range, and we have 6 times as many straights or sets as our opponent does. So the hand versus range equity, the problem with using it is that it attributes some value even to flops which heavily favour our opponent's range. So on the Ace-Jack-7 flop, our opponent has a huge range advantage. He's 65-35 and 3 times as many sets. So consequently, he's going to be able to continuation bet the flop with a high frequency. And every time he c-bets the flop, we have to fold our Queen 8-7 deuce, and so our payoff from the hand is we just lose the 2.5 big blinds that we invested additionally to that 1 big blind that we posted pre-flop. So on the Ace-Jack-7 flop, whenever our opponent c-bets, even though we have 18% equity, it plays as if it was 0. This example serves as a basis for us to dive deeper into our model that helps us to understand the interaction between strategies and payoffs. So we saw that on the Ace-Jack-7 flop, whenever our opponent c-bets and we have to fold, our payoff is minus 2.5 big blinds. So the graph here is a dual axis graph. What I have is, in the background, there is the hand versus range flop equity distribution that you saw earlier, and the frequency is graphed on the left hand side there. And then on the right hand side, I have put an associated estimated payoff for having a given equity. Now, of course, in practice, it's not going to be as simple a mapping as this, but I wanted to use this as representation because since we prefer to continue with hands that have greater equity against our opponent's range, we can basically choose some threshold equity below which our payoff is going to drop off to that minimum, hopefully, of minus 2.5 big blinds, where we just always fold, irrespective of whether we hold 10% or 20% equity. So a couple of things I want to make clear. First of all, strictly you'd want to use your opponent's equity against your equity against your opponent's betting range and not against his entire range. I didn't want to add that level of complication, but if some of you are picking this up quite quickly or have worked with this a bit before, I wanted to share that. Secondly, I have not solved this situation. So 30% is just an example. Do not take 30% as gospel. That's the equity you need to have to continue on this board. It's just an example of, it's going to be in the region of that, bluntly. It's going to be in the region of that because the range advantage is so strong for your opponent. So nothing special about 30%. It's just the spot that I've chosen for this example. So hands with equity below this are all effectively worth the same amount facing a flop c-bet. So you can see the difficulty with using average equity because average equity is including, as having value, equities of hands that are just folding every time to a c-bet. So we now understand the limitations of using these hand versus range flop equity distributions to guide our pre-flop decisions. Flop equity distributions combine flops which favour our range with those which favour our opponent. So put formally, flop equity distributions show us the hand versus range equity without the context of the range advantage. Your hand versus range equity takes place in the context of a range versus range equity. So if the board favours your range, then you'll get to see free turns and rivers more frequently. As a consequence, the hands in your range which have lower equity are going to have better payoffs. If the board favours your range, then you will also be able to build pots with your strong hands for bigger payoffs rather than using them to protect your weaker hands in your range. And if the board favours your opponent, you will see free turns and rivers less frequently, and so the hands in your range with less equity will have worse payoffs. If the board favours your opponent, you will also pay more on average just to get to showdown, and so even the hands in your range which can continue past the flop will have worse payoffs. We're now going to build a hand versus range river equity histogram. So again, we use Odds Oracle. The steps in each trial are that we start with a specific flop, we deal the turn and river, we calculate the hand versus range equity for that river, and then we assign this hand versus range equity instance to a bucket on a histogram. Again, we repeat the process for n trials, where n is a number you set. For this example, I used 8,000 trials. So a finished graph looks like this. We've got our queen 8-7 deuce, poor queen 8-7 deuce, facing a 12% open on this very favourable flop for our opponent, the ace jack 7. And as you see, there are no flops where the queen 8-7 deuce is getting even past 80-something% equity, because the aces is going to dominate any potential run out that we could make, even if a straight appears, so that the straight we have viable will be the 10-9. Of course, that completes the king-queen, and then we see that there's this big spike of about 27.5% of flops where we have 0% equity. So there are plenty of situations where our opponent's entire range essentially beats us, and then most of the hands are bunched at sub 10%, but we've got a smattering between 20 and 60 dispersed at regular intervals. So we represent the river equity distribution on a flop F for a hand H against a range R, a lot going on now, as Z, F, H, R, F in the superscript, H, R in the subscript. So here I've got an example of king, king, deuce, deuce versus this 12% open on ace, jack, 7. And here you see, because you can at least run a runner, well, you can run a runner quads, but I think more frequently this spike near 100% is going to be you runnering the backdoor flush draw. So you see that you've at least got some nut potential with this hand, and because it has higher equity than the other hand that we just saw, the queen 8-7 deuce, it's also, when it spikes a set with a king or spikes a set with a deuce, yeah, it's not a nut hand, but it's still a hand that's going to beat a large fraction of your opponent's range. So holdings which can make nut hands by the river, in general, will have some frequency of near 100% hand versus range river equity. So I said near, because there are a number of factors that can take it just away from 100%. So one example is whenever a straight has appeared, your opponent will always be able to have that same straight some fraction of the time. So you won't have 100% equity against his range, you'll have 90-something, because sometimes it's a split pot. Very high hand versus range river equity enables you not only to bluff catch, because when it's very, very high, if you're ahead of your opponent's value range even, for sure you're going to be able to continue, but also to even build a very big pot for value. So there are situations where your opponent bets on the river, you might have decent equity against his betting range, but if you raise, then you will narrow his range to a set of hands which beat you, so you can't. Whereas when you have very high equity, you can still raise for value. These are payoff asymmetries. So the payoff asymmetries mean that one hand could have less equity than another on the flop, but be more profitable to continue past the flop with, because it can withstand and build bigger pots on certain runouts. So now we've got all the different factors in our model explained, we're ready to replace this old equity share model with our new payoff function model. We're going to represent strategy pairs as some strategy S for the given player and the given player strategy selected from any one of a number of effectively infinite strategies you could choose. So S is the complete description of a player's post-flop strategy for every hand in his range under every contingency. So contingencies would include more common situations, such as when a player c-bets, or when the flop is checked through, but also the weird situations, such as the response to a double check raise. And I say weird in a kind of loaded way, that's because these are rare situations for us in the current meta. It doesn't actually mean that when we actually start solving some of these spots that you're going to find that some strange spots like, well, double check raising is a bit extreme, but certainly delayed c-bets should be represented much higher when you start building near optimal strategies. We represent flop payoff functions as U to denote the payoff for a given player, and then player 1 strategy and player 2 strategy as a strategy pair is put there. So as an example, here U11 is going to be the flop payoff function for strategy 1 of player 1 versus strategy 2 of player 2. So if your opponent chooses a strategy that matches up poorly against your own, your payoffs can improve either because more of your hands become profitable to continue with, or the hands which you continue with become more profitable, or both. So we're almost ready to complete our model, because we just need to discuss pre-flop payoff functions now. What have we learned so far? That the equity share model is terrible for making pre-flop decisions because it disregards how the range versus range context affects the hand versus range post-flop play. Hands with equity below a binary threshold are all effectively worth the same amount when you face a flop continuation bet, And the consequence of payoff asymmetries is that a hand with nut or near nut potential can have less equity than another hand, but be more profitable to continue past the flop with. So the extent of the flop range advantage and the strategies that both players take determine the flop payoff functions. The superposition of all of the possible flop payoff functions combine to create a pre-flop payoff function, and it is the pre-flop payoff function which tells you whether the given hand is a profitable pre-flop call in a specific range versus range context. So the reason that pre-flop decisions are so important is that the ranges you choose pre-flop determine the set of flop range versus range context that you can expect. I hope you enjoyed the video. Thanks for watching and good luck at the tables.